Hi guys. Okay. Okay. So I think there was a technical glitch. So let's start from question number. So let's go to the previous one. Yeah. So let me start from this question. Question 4 to 6 once again. Then we go through. Sorry for the technical glitch. So now quickly. So for question 4 to 6, we have another circuit here. And this circuit below has got 12 volt source here and a 4 series resistor, which you clearly see 8 ohm shunt. Okay, our problem here is find the open circuit, that's the Thevenin voltage across the terminals A and B. So we need a voltage across the terminal A and B, our VTH. Okay, now analyzing a circuit like this, please, this is a simple circuit. Don't worry yourself, go and find I1, I2 and all that. Please take note. The current produced by our source here, labeled I, will pass through 4 ohm. Upon reaching this junction, we'll have no other option except by coming down. Okay, once it comes down, it returns back to the source. It doesn't flow through because this is an open circuit. There is no chance for it to move. Because of that, our effective circuit lies here. In the presence of our source, 4 ohm and 8 ohm are in series. Please take note, there is a tricky thing here. These two are in series in the presence of our source. In the absence of our source, it doesn't become in series. The reason why it's in series in the presence of our source is electron will flow here. Upon reaching here, we'll have no option because this is an open circuit, right? So let's find the Thevenin voltage. We need the current I, only I. So I is equal to total voltage over total resistance, right? The reason why we are finding I is we want to use the voltage drop approach. Whenever they give you a very simple circuit, use the voltage drop approach. It's very fast. Please work with time. I is equal to the total voltage over the total resistance. Okay, what my total voltage is 12 volts over my total resistance, which is going to be 4 plus 8 because they are in series like this. So that becomes 12. So my current is simply 1 amps, 1 ampere, 1 ampere. If my current is 1 amps, then it means that the I here, which is 1 amps, will flow through this 4 ohm and drop a voltage of 4 times 1, which is 4 volts. If it drops 4 volts here, it means that the residual voltage will be what? 12 minus 4. So 12 minus 4 will give us 8 volts, and that 8 volts will be dropped across here. So meaning that the voltage across the 8 ohm here is 8 volts. But please take note, if you are tapping in parallel or across a resistor, the voltage across the resistor becomes the same voltage you read. So here our VTH is simply equal to the 8 volts across the 8 ohm. We come here and that is C. Congratulations if you got it right. Now let's go to question 5. For question 5, he said that with the 12 volts replaced by a short circuit, we should calculate the RTH. So I clean this and I'm going to have my circuit come back to what I'm looking for. So meaning this has been short circuited. So this one becomes like this. Once this branch becomes this way, it means that when there's no current here, we are going to use for illustration. We use our basic principle for parallel and series connection. The presence of a node will prevent these two resistors from being what? In series. Therefore, they are in parallel. When I traverse through their path, they are the only two elements here. Please take note. Therefore, my total resistance becomes 4 times 4, 4 times 8 over 4 plus 8. That is 32 over 12. And that gives us 2.67 ohms. Correct. Please take note. The total resistance between this, which is, we are finding our RTH here, okay? And the RTH is simply the resistance here, right? So now we have our VTH as what 8 volts and our RTH as what 2.67. So let's move to the next question. It said that a 4 ohm load is connected across A and B using Thevenin equivalent. You should find the load current. Our load current is always equal to VTH over RTH plus the load resistor. What is our VTH from the question? 8 volts over our RTH, which is all 2.67. plus now the load resistor is what 4 ohm, which you are looking at here, 4 ohm. Therefore, you enter this 8 over 2.67 plus 4, okay, and that gives us 1.99, which is the same as he said closest. This is the keyword, closest. Therefore, it's 1.2 amperes. Correct. Congratulations if you got this. Question 7. To find VTH across any two terminals of a linear network, the correct procedure is A. Short the terminals and measure current. Oh no. B. Remove the load, open the terminals and measure the voltage. Yes. Connect 1 ohm test resistor. Oh no. Then we have deactivate all sources and apply test voltage. No. Therefore, our answer is what? Simply B. Question 8. When finding RTH for a network with independent sources, you must, to find RTH, what do you do? A, he said short all current sources. Oh no, we don't short current source and open all voltage sources. No, we don't do that. B, short all voltage sources and open all current. Yes, this is true. Right. Then we have leave all sources active. No, we don't leave all sources active. Short all sources regardless of type. Oh no. Therefore, the answer is what? Is B. Right. Now let's come to another our set of question number 9. Number 9 says in the circuit above here, 30 volts has been shorted. So this where the 30 volts supposed to have been. It has been shorted. Now we are supposed to find we are supposed to he said that we are supposed to find the RTH as seen between the terminals A and B. Okay. So as seen between the terminals A and B, if this has been shorted, then obviously this and this are in parallel. So 6 times 3 over 6 plus 3. I think this is a repeated question. Plus 6. That gives us our total resistance. So this is 18 over 9. That is 2. So our answer is 8 ohm. So we move to the next page. So we come here. So the answer is 8. So it was a repeated question, bonus. Now, okay, we move to section B, 10 to 12. This is nothing. Um, this is nothing current problem. Okay, nothing's current problem. Now, there is this slight issue with this diagram, so let's skip this to the nothing's term. So this another one. Let's skip this and let's come back. Yeah. So let's start from here. Question 17. So we come back to the question 10. Now, it says the conversion between Thevenin and Norton's equivalent follows a relation. You know that Thevenin and Norton, please, there is a relationship. The Thevenin's current, okay? The Thevenin's current, the Norton's current IN is always equal to Thevenin's voltage over Thevenin's resistance. That's a very powerful relationship between Norton and Thevenin. And what is the answer? IN is equal to VTH. Oh no. So let's observe it here. And you realize that RTH is the same as RN. It doesn't change. RTH is equal to RN. So which of these will give us the right one? So we say that VTH is equal to IN times what? RTH. It should have been IN times RTH. Or let's see. So let's see A. A is saying that RTH is not equal to RN, so it's not part at all. B is saying that RTH is equal to RN, then it means we can consider. Therefore, VTH is equal to IN over RN. Yeah, this one too is perfectly right. So B is right. C is saying that RN is equal to the reciprocal of RTH. Oh no. Then D, RN is equal to no, RTH is equal to this. No. So the answer is what B, if you got that right. Now, question 18. In the diagram above, terminals A to B are short circuited. Okay. If VTH is 24 and RTH is 8, then the Norton current is equal to. So there's an application here. Sometimes students get these problems and they will be. I mean, this here is a tricky thing here. Okay, it is just lying to you. You'll be tempted to. I mean, try to find. No, don't solve. Once you are given VTH and RTH, your Norton's current is equal to 24 over 8, and that is 3. As simple as that. 3. So we move to the section C. Okay, these are in sections. It's talking about superposition theorem, right? So there is a preamble here saying that we should use superposition to solve question 19 to 21. The circuit below has a 10-volt voltage source, a 5 amperes current source, and resistors 2, 4, 6. Okay, let's see what this question is. Look at our circuit here. Here's the circuit which they are talking about, and we have two sources. We have current source, wow, we have voltage source, and we have 4 ohm, we have 2 ohm, we have 6 ohm. With the 5 amps current source open circuited here, the current through the 6 ohm resistor due to the 10 voltage source alone is a perfect problem in superposition theorem. Just that mostly students get problems where you are given only voltage sources, but when they give you a mix of voltage sources and a current source, this is how you approach. But this is a very simple circuit. So whenever you have a current source, it is open circuited. Okay, open circuited. So we assume that this has been broken into two. This is my voltage source. I will need to find the current. He said, find the current through the resistor 6 ohm. This is my 6 ohm. That is due towards a 10-volt source alone. Let's see something here. So ideally, this one just move straight, finding your current I will have no other option except passing through 2 ohm, right? Upon here, let's see something. Source here. So that we should open circuit this. So apparently we realize that there's no current which is supposed to have what flown through, right? So let's see something here. We realize that my I here will pass through this and we'll have no other option except to pass through here. We need a current in the 6 ohm, okay? But let's see something here. Now, if I want to find my total resistance using 2 and 4, what am I getting? I'm going to get 6, right? Because it's in series. Once I open this up, here, there is no current. So it will be like this. I'll have my voltage plus and minus. That will go into the 2. Will come down into the 4. Then will come to the 6. And it will hang like this. Can you imagine? So obviously, this is an open circuit. In an open circuit, current will flow through here and will come. But here we want to find the contribution of 10 volts to this. So let's see how we are going to do this. Considering 2 and 4 as the only resistors which are active, I'll have my resistance to be 2 plus 4. And this is equal to what? 6, right? This is equal to 6. So if this is equal to 6 ohms, what happened? We are also going to have the total voltage to be equal to what? Total voltage is 10 volts. Okay. So let's see something. Yeah, so we have the voltage to be 10 volts. So here, sorry for the break. Okay. Yeah, so let's see something here. Now, this one is a very interesting problem. Okay. So this is what you do. Whenever you are finding, whenever you want to find the current contribution, whenever you have a current and a voltage source, it's very controversial. Okay. So we have this going to be open here, right? As I said. So you ignore this and let's see the contribution directly from here. So here you simply have to introduce your current I here, right? Then you realize that the total current becomes this and this being in parallel. Okay, this and this being in parallel. So we are just trying to say that deactivate the source. So we are not going to put into consideration the fact that we have opened it so that the current is not flowing. Okay, so we are just trying to deactivate it. The only way to deactivate a current source is by opening it. Okay, so let's see. We are going to get 4 times 6 over 4 plus 6, and that gives us 2.4 for the parallel connection of this and this. It should be in series with the 2. Therefore, my total resistances become 2 plus what? 4. 2 plus 2.4, right? And that is equal to, let me clear this. So I'll get 2 plus 2.4, and that is equal to 4.4. So here simply, my total current I becomes 10 out of 4.4. And the answer is 2.27. 2.27. So my total current I coming from the 10 volts is 2.27 amps. I want a current that will be passing through the 6 ohm. This 2.27 will pass through the 2 ohm, right? Then upon passing through the 2 ohm, what happens here? There is a voltage drop. Is that not it? Yeah. So the voltage is dropped. So once the voltage is dropped here, I'm going to have 2.27 times what? 2, right? So 2.27 times 2, what do we get? Yeah, hello. As a former beta tester wizard. Yeah, hello. Hello. Okay, so I continue. So at this point, we found the current to be 2.27 amperes, right? And now you realize that at this point, this current will what have to split. And upon splitting, this is where we apply what you call the current division. Okay. So what's the current contribution? That will be passing through the 6 ohm. That's our point of interest. And that is simply equal to 4 over 4 plus 6 times 2.27. Is that not it? So using a simple current division, you are going to get 4 over 4 plus 6 times 2.27, right? What's the answer? 0 point. So I'm getting 4 over 10 times 2 point 0.9. So 0.91, right? So let's see. This gives me my I of 6 ohm is equal to 0.91 ohms. Okay. So actually, these types of questions are a little bit tricky. Okay, please take note. So our answer is E, 0.91 volts. And also, I learned that sometimes your answer may not be in, but that doesn't mean that you are wrong. So you always have to choose the closest configuration, especially when your values are approaching decimals. Okay, so the closest configuration should have been what? We have 0.91, so we have 0.80 here, right? So but nevertheless the answer is 0.91 volts, right? He said with the 10-volt source short circuited and the 5 amp current acting alone, the portion of the 5 amps that flows through the 6 ohm resistor is. So now let's do the other way around. Oh no, I cleaned the. So here is E, 0.91 amps. So let's go to question 20. So for question 20, our 10-volt source is short circuited, right? So we are going to short circuit it. Once you short circuit it, then it means that we have to find the contribution of the current across this. As simple as that. This can also be easy but very tricky, right? So okay, so we have our current source here, which is what? 5 amps. Okay, so the current source here is 5 amps. We want to find the current contribution of these 5 amps only, which is influencing the current that's going to pass through this. So this one has been short circuited. There is nothing here, right? There is nothing here. So since there is nothing here, now I have this as my current source coming. This is the only current source I have, right? So this current source that you see, you realize that it's going to produce when you say current source, and this is an ammeter which is measuring the current across this branch. But now the argument is that why is it that they don't say straight away that the current contribution of this is what is simply the current which is flowing through this 6 ohm, right? Yeah, so actually the current measurement. So the question said that with the 10-volt source circuited, the 5 amps current source acts alone, right? The portion of the 5 amps that flows through the 6 ohm resistor using current division is. So they even stated clearly that we should use current division, right? They said that we should use current division to solve this problem. So now, if you have a current coming here, then it means that we need to get two branches. Sorry, we need to get just two, right? So we realize that I have this 2 ohm and this 4 ohm, right? So this 2 ohm and this 4 ohm here. Now would we say that they are in series or parallel? This is in parallel, perfect parallel. And we have this 6 ohm here. So current division here, now you have this arriving here. So it's going to split here and it's going to split here. But even with that, there is this 6 ohm here. So I think this question current division here wouldn't work for this particular scenario. Okay. So we simply go by it's simply the 5 which is arriving here, which is passing through. So um we just move straight to the question 21. It says that the total current through the 6 ohm, right, when both sources are simultaneously active is found by.